Let's review what you've learned about the relationship of the quantity of reactants to the quantity of products in a balanced equation. So if we look at the following equation, or reaction, we see that we've learned to understand that this 4 and 3 and 2 and 6 can represent molecules, but it also can represent moles. And so hopefully you're comfortable with the idea that 4 moles of NH3 reacts with 3 moles of O2 to form 2 moles of N2 and 6 moles of water. We've shown or worked multiple problems to show that if you take the molar masses of each of these reactants and products, multiply it by the coefficients, you then prove the law of conservation of mass, that you start with the number of grams that you end with. And in fact, this should say grams per, just grams equals grams, because we've already multiplied it out with the coefficients. Now we've done quite a few problems where we were trying to help you, or I was trying to help you understand that these coefficients represent ratios of elements. It's not math like 4 plus 3 equals 7. It's a ratio that 4 to 3 gives you 2 to 6 of the products. And so if it ends up that you're trying to produce a number of moles of the product that doesn't exactly marry up with what's in the balanced equation, you can still figure that out using what we have ended up calling the mole ratio. So in this problem, how many moles of oxygen are required with excess NH3 to produce 15 moles of N2? And so we set up this dimensional analysis problem and determined that we need 22.5 moles of O2. Some of you are having a little bit of trouble with the dimensional analysis, so I'm trying to help you understand that you can set up comparable ratios. And you can do that throughout this whole process. It's just a little more tedious. Just be aware that when you set up this comparative ratio, that what's on the top is the same molecule as what's on the top on the other side of the equation and over here. So it's O2 over N2 equals O2 over N2. Typically, it's better if you put the variable in the numerator. Now with this problem, we've added one more step to the analysis of this balanced equation. So in this one, we're looking for how many grams are needed, and we're starting with a set number of moles. So we're starting, there'll be a problem on the next page, and we've addressed this before. Well, sometimes you're actually looking for grams, but in this one, you're starting with grams and you're looking for grams, but in this one we're starting with moles. So I'm going to call that step B. It's kind of the middle step of this process. Sometimes this whole process is called gram, mole, gram conversions. And so with this problem, we're starting here with that mole conversion. This is exactly what we did on the other page, where you're comparing ratios from the balanced equation. This right here for 4NH3 to 3O2 is from this balanced equation here. Now, in this way of doing it, the dimensional analysis, I'm multiplying these two things out, and that's why I'm allowed to put on the bottom what I want to get rid of, and on the top what I want. Now, if you choose to do the problem like this, then you're comparing ratios and you're putting equivalent ratios on either side of an equal sign. And so in this case, you have to put the same molecules in the numerator as you do on the left and right side of the equation. But you end up with the same answer here, 10 moles of NH3. And then to convert it to grams, we've done this multiple times. To go from moles to grams, you multiply by the molar mass. A common problem kids make is they don't put the right molar mass in here. Make sure that you're aware of what you're getting the grams of, and you're putting in the molar mass of that. So the molar mass of NH3 is 17 nitrogens, 14, and 3 hydrogens would be 3. Okay, and this is the most complicated problem we'll do. It's a 3-step problem, step A, B, and C. And this is your classic gram, mole, gram problem. So we're starting with grams. We're going to convert it to moles. We're going to convert those moles to the moles of the unknown from the mole ratio from the balanced equation. Then we're going to convert it to the grams of the unknown. So the first thing is we're convert grams of N2. So we're looking how many grams of NH3 are needed to react with excess O2 to produce 5.54 grams of N2. So the first thing I do is I change 5 grams of N2 to moles of N2, and molar mass of N2 is 28. Then I take those moles of N2 and see how they compare from the mole ratio, the balanced equation, to moles of NH3. And I get these numbers right here from this balanced equation. I find 0.198 moles of N2 required, 0.396 moles of NH3. And then the final step here is I take that and multiply them by the molar mass, which is 17 for NH3. I get that it required 6.73 grams of NH3.